Hi there everyone, and welcome back to 7th grade math, chapter 4, section 5. We are going to be working on adding and subtracting mixed numbers. I'm going to do a little bit of a review on mixed numbers first, and then we'll jump into textbook page 300 through 302. Be sure to remember to write down everything that you see. Once again, you're reminded that you've got some new things on this page here. You definitely for this lesson want to have some colored pencils or some colored ballpoint pens, and you want to have your pencil with eraser, headphones so that you can focus on what is being taught in the math lesson. You'll definitely need your math textbook out and some lined notebook paper. And you can notice two new icons here on the page. We've got one that says good mathematics is not about how many answers you know, it's how you behave when you don't know. So we're going to be focused on that for the next couple lessons and trying to make sure that we can continue to push ourselves to find the right answers. And you'll see my cute little math smiley face because I want you to bring your happy math attitude. On the next page here, you're going to see the heading that I would like you to write at the top of your paper. It says mixed number review, and I'd like you to write your name, date, and period in the top right corner, and then, if you could please write the fraction, or the mixed number rather, 3 1/4. So 3 1/4 is the mixed number that we're going to work with just briefly so that I can show you exactly what each piece is. Now, I know that you're familiar with this, and many of you probably even know it back and forth, but I just want to make sure before I get started with the lesson that we have the terminology. So the 3, which I've used the pink letters for now, says whole number. So that means you have 3 wholes, and then you have 1 of something that's cut into fourths. So what that also means though is that those 3 wholes can also be cut into fourths. So I'm going to show you what that looks like here with the blocks. So notice you've got the 3 wholes. Now they are cut into fourths. The reason I know they're cut into fourths is because my denominator is 4. So now you're going to see that you have the whole number 3 right here. Now there's still one more piece we need to add to it. We need to add the 1/4. So I'll show you what that looks like as well. All right, so now you can see one more block here, but I want you to notice that nothing is shaded in the block. So the numerator in our fraction, that number 1, indicates that we have 1 out of these fourths here that is also counted. All right, so now you can clearly see with my pink shaded in area that we have 3 wholes, and then we have 1 out of 4. So the denominator here is into fourths. But what that really means too is that all of our wholes are cut into fourths too. So if you take just a moment, watch where I'm going with the green pen now, because I want you to make the relationship, the connection between a mixed number and an improper fraction. The reason I know that these 3 wholes are cut into fourths is, remember, again, because of the denominator. So now I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means I have 13 and everything is cut into fourths. So that's how you get the improper fraction if you're actually doing it with a diagram. You have 13 slices and they're all cut into fourths. So remember that the denominator stays the same because the number of slices that they're cut into never changes. So now we're going to move on to textbook page 300. So wherever you're at on your page, you can do a little squiggly line and write textbook page 300. And on this next screen, you're going to see an example. So with the example here, whoops, I went 1 screen too far, 2 screens too far. It says, are the denominators in the fraction the same? So we're looking at the fraction, not the whole number portion first. And we're looking to see if the denominators are the same. In this example, you can see that the denominators are 9. So since they're both 9, then that means both the numbers, even their whole blocks, are cut into ninths. So it'll be cut into 9 pieces for each one, even their whole blocks. So that means we can actually add and subtract just the way that it is. We don't have to do any changing. So in red it says to add or subtract the numerators of the fractions first. So this is an addition problem, and you can see that with the plus sign. And the numerators that I have are 4 and 2. So if you take a look at the 4 and 2, 4 plus 2 is 6. That's where I got the 6 that is in red. Then it says to keep the denominator the same, because remember, the number of slices that each block is cut into is never changed. So you want to keep the number the same, so that should be ninths, and then it says to add the whole numbers. So now we have 7 plus 10 is 17. So the last piece, we have our final answer here, which is 17 and 6/9, but then the very last thing in pink says to simplify. So we do need to divide each of these by 3, the 6, and the 9, and that would give us 17 and 2/3. Don't forget to leave the 17 alone when you simplify. The whole number is not involved in simplifying the fraction. So now I'm going to give you just a little reminder about MAD, and this is just to remind you, let me go back a step here, sorry. This is just to remind you the steps in multiply, add, and denominator. Now these are the steps to change a mixed number to an improper fraction. So that's what you want to write on your paper. You can draw a squiggly line so that you're able to differentiate between the last piece and this one. But when changing a mixed number to an improper fraction, you want to use the example that I have here, which is 2 3/4. Now I've got the 3 steps listed here, which are multiply, add, denominator, but I'm going to use my red pen and my blue pen and my pink pen. So the blue pen, see it says multiply, so I'm going to use that right here. We're actually going to multiply 4 times 2, and you can see that right here, and I've also outlined it with the blue box. Now in your head you can just say, okay, 4 times 2 is 8. Perfect, now we know that. Then we have the plus sign here because we have a plus sign right here, and our next step says to add. So we're going to add that 3 that you see right there. So now when you have 8 plus 3, you get 9, 10, 11, which is where we get this answer of 11 right here. And remember, the denominator stays the same. You leave the denominator alone. So now you have 11/4. So hopefully that was just a quick reminder of changing a mixed number to an improper fraction. And now we're also going to do a quick reminder on how to change an improper fraction back to a mixed number. So in this problem, you see 28/5. So 28/5 is the same as actually saying 28 divided by 5. Remember, the roof goes over the top of the 28 and the 5 goes on the outside. Then you would divide like normal. Well, you'll see that in pink, I wrote a little r right there because 5 times 5 is 25, and then you have 3 left over. So 5 becomes your whole number. See the blue arrow that I have pointing down to the large 5 at the bottom? And then 3 is your remainder, so that 3, the remainder, becomes your numerator. Remember, that's the number on top. And 5 is the denominator because the denominator always stays the same when you're converting back and forth, because remember, the number of slices that each hole is cut into is still the same. So that's why you keep the denominator the same, just so that you have the reasoning for that. On this page, you're going to see what you need to do now for the other type of problem, when you have a problem that has different denominators. So our problem here is 8 5/6 minus 2 1/3. So for 8 5/6 minus 2 1/3, you should immediately notice that your denominators are not the same. Since they're not the same, before you can actually go about making them the same, you have to convert them both into improper fractions. And the reason you have to do that is because you can't talk about 8 wholes that are cut into maybe fourths and compare that to 2 wholes which are only cut into thirds, let's say. So that's why we have to first convert it to an improper fraction, so we can put that whole number back into the top of the numerator, and now we can rename the fractions to have the same denominator. So as you can see in blue, I have done my multiply add denominator. So 6 times 8 is 48, plus 5 is 53, so 53/6. 3 times 2 is 6, plus 1 is 7, and so you get 7/3. And now it says to rename one or both fractions, get a common denominator, to get a common denominator. All right, so just so it's a little bit less overwhelming, I have erased some of the stuff so that we can bring it in gradually. So first I went ahead and changed them into improper fractions, and now we need to rename one or both of the fractions to get a common denominator. So I did make that change as well. So let's go ahead and see what that looks like. So obviously 6 is going to be my common denominator. Now to get from 3 to 6, I multiply by 2, so on top I'm going to multiply 7 times 2, and I get 14/6. So now our new problem is 53/6 minus 14/6. So the last piece here that says I need to add or subtract the numerators, which I got 39, and then I'm going to keep the denominator the same, so I got 6. And then step 5 says to simplify, which means reduce or convert back to a mixed number. So in this case, I did not have to reduce right away. First I had to change it back into a mixed number. So now we have 6 3/6, and then I had to simplify to reduce the fraction. So hopefully that is helpful for you. What I would like you to try and do now is the got it problems. So on your paper, if you'll go ahead and just do the got it problems, if we could say, go ahead and pause your video and you'll be doing A, B, and C, but first I want to show you how you should be setting the problems up. So if you'll notice in the first examples, we set them up and down. You should probably too as well, but you can actually set them up either way. Either way would be fine. So for instance, for A, we've got 6 and 1/8, but you are going to need to set up the original problem regardless of what you choose to do. So 2 and 5/8. So now the first step, remember again, and I'm going to pause right here so that you can go through A, B, and C. Go ahead and do that now. Welcome back. I hope you paused. So now let's go ahead and look at the problems as we have them. So the first thing I notice, because I've asked myself, is are the denominators the same? And they are. So since the denominators are the same, then I'm going to add the fractions first. 1 plus 5 is going to give me 6, so I know I will have 6, and then I keep the denominator the same as 8. And then I am going to have the whole numbers added together. So 6 plus 2 gives me 8. But remember, you're not finished yet because you need to reduce that fraction. So instead of it being 8 and 6/8, it's still going to be 8, but we're going to divide out 2 from both of these. So I'm just going to do that here with the green. You'll see dividing by 2 and dividing by 2. So remember, I keep the 8 as it is. And then when I divide 6 divided by 2, I get 3. And 8 divided by 2, I get 4. So now my final answer is going to be 8 and 3/4. And don't forget to put your box around it. I'm going to set up the next problem a little differently. So I'm going to set that one up and down, or vertical. So for B, you'll see that I have 5 and 1/5 and 2 and 3/10. So immediately you should have recognized that your denominators are different. So the first thing that you need to do, even though you're going to be totally tempted to change the denominators, you are not going to change the denominators. Remember, you need to first change them into improper fractions. So 5 times 5 is 25, plus 1 is 26. So you're going to put 26 over 5 because you'll keep the denominator the same. And we're going to be adding that to 2 times 10 is 20, plus 3 is 23. So it'll be 23 over 10. Now again, we haven't gotten common denominators yet, but we are one step closer because now we have improper fractions that we can convert using, or we can rename rather, with common denominators. So now we're going to go back to that questioning where we go, okay, does the small fit into the big one? And it does. So the common denominator in this case is going to be 10. So I'm going to write a 10 right here next to the 5. And to get from 5 to 10, I'm going to multiply by 2. Let me take that arrow out and just show you. Multiply by 2. Whoops. So when I multiply by 2, I get 5 times 2 is 10. And on top, 26 times 2 is going to give me 52, I believe, right off the top of my head. So now we have 52/10 plus 23/10. So only now that we're comparing essentially apples to apples, because now we have a common denominator, can we actually do the adding. So now let's go ahead and do that. So now when we add our numerators together, 52 and 23 give us 75. So we're going to have 75. And remember, you keep the denominator the same, so it'll be 75/10. And now you need to change that back into a mixed number. So you have to ask yourself, well, how many tens can I get out of 75? Well, you will be getting 7 whole numbers out of it. 7 times 10 is 70, so you'll have 5 left over. And so it'll be 7 and 5/10. But remember, you're going to have to simplify it. So you're going to have to get that all the way back down to 7 and 1/2 because you'll divide out by 5. But keep in mind, just like we said before, the whole number is not affected when you simplify the fraction. And don't forget to box your answer. All right, so we see another problem with not having a common denominator. So I'm going to go ahead and speed through this and get that into an improper fraction. So we come up with 14/9 and 25/6. And now I need to change this improper fraction to have a common denominator. So does the small fit into the big? 6 does not fit into 9 equally. So now I need to take the larger one. Remember, this was my 2, 3, 5 strategy. And I need to say, okay, 9 times 2 is 18. Can 6 fit into 18? Yes, it can. So this is a situation where you definitely don't want to go all the way up to 54 because 18 is your least common denominator. So now we add our numerators up. We get 75 and 28. So 75 plus 25 is obviously 100, plus 3 more would be 103 over 18. So now we have to find out how many times 18 goes into 103. Beginner's luck, I got 18 times 5 is 90. So that's going to give us 5 wholes, and we will have 13/18 left. So it'll be 5 and 13/18. For D, you're immediately going to turn those into improper fractions, and then you're going to rename with a common denominator, which will be 10. So now you get 71 over 10, which when you turn it back into a mixed number is going to be 7 wholes, because 7 times 10 is 70, with 1 left over and a tenth. So you have 7 and 1/10. Don't forget to box your answers. So as you can see, I went ahead and changed them into improper fractions first, and then I found a common denominator, and now we're left with 111 minus 78, basically, which should be, as long as this late hour isn't playing tricks on me, 33, because it was a subtraction problem, over 8. Then we need to change that into a mixed number. 8 times 4 is 32, and then we have 1 left over, and 8 is our denominator. Then you want to, of course, put a box around your answer, just like that. You should have come up with the answer of 43 over 6, and you want to change that back into a mixed number. And since 7 times 6 is 42, it's going to be 7 with 1 left over out of 6. And then, of course, as usual, you want to box your answers. Hopefully you had enough practice problems to really catch on to that concept. Now we're going to be looking at textbook page 301 at the top, example 3. As you can see with this problem, 2 1/3 minus 1 2/3, we have a little bit of a problem here. The denominators are the same, which is great. So normally we would just subtract the numerators. However, 1 minus 2 is going to give us a negative number. So this works a little bit differently with mixed numbers. What you want to do is notice how the 2 1/3, I'm going to go ahead and draw a little diagram for that. So I recopied the problem up and down just so that I can show you the bars like this. So for 2 1/3, what you're going to see is that it would be shaded like this. You have 2 holes, so this is a hole, and this is a hole, so this is my 2, and then I have 1 of the thirds. And then you have 1 2/3, so that means this hole right here is good, that's 1. So this is 2 up here. This is 1, and then you have your 1/3. I'm sorry, 2/3. So then you have your 2/3 here, and up here you have your 1/3. So hopefully you're able to follow along with my diagram here. So that's what that represents. Before you can subtract, you need to borrow from the 2 whole. So when I'm talking about the 2 whole, I'm talking about right here, because you can't do 1 minus 2 when you're talking about the mixed numbers. So what you need to do is actually borrow one of these groups. So one of these groups right here. So you're going to borrow those 3 slices, and you're going to add them to the top of the numerator. So your new number is now going to be, and you haven't actually changed it at all, you've just renamed it. So what you're going to change it to is going to be 1, because remember you had to borrow. So now you have 1. But remember you borrowed 3 slices of pie. So that 3 slices in that blue bracket. So you're going to add 3 plus 1, and that will give you 4. So I know that looks a little weird, but now you have 1 4/3 minus 1 2/3. So now you can do your subtraction just like you would before. So now you have 4 minus 2 leaves you with 2. And then, of course, you keep your denominator the same. So we're going to have 2/3. And then 1 minus 1 is 0. So our final answer for this particular problem is going to be 2/3. So method 2 for the same problem, I do want you to write method 2, example 3, is going to be to just change them into improper fractions and work with them the old-fashioned way. So 3 times 2 is 6, plus 1 is 7, so we get 7 over 3. And then we have our subtraction sign. 3 times 1 is 3, plus 2 is 5, so we get 5 over 3. And now we have 7 minus 5 leaves us with 2. And so our final answer here, again, same answer, is going to be 2/3. So as you can tell, either method works. You are welcome to use either method. Moving on. So now you want to pause the video and go ahead and try the got it problems. After you finish G, you want to unpause the video to make sure that you get that right, since this is one that is kind of new to us. Now this problem was a little bit tricky because you have a whole number minus a mixed number. So I'm going to show you with pictures as well. So in my picture here, you can see that I have drawn 7. Now you may ask yourself, how did you know to split that into 2s? Well, I split it into halves because I'm going to be comparing it to 1 1/2, which means my slices are cut into halves for the 1 1/2. So hopefully you can understand that below, right here, is my 1 for my whole number and my half for my fraction. So as you can see, I have 7 wholes, but they're made up of 14 little pieces. So now, if you can stay with me, I'm going to cross out 1, 1, and then a half of 1, okay, to cover that half of 1. So now I'm left with 1, 1, 2, 3, 4, 5 wholes. So I'm going to put that in my answer down here. I have 5 as my whole number, and then I have 1/2 left. So it'll be 5 1/2. And then you want to put a box around your final answer. So for this problem H, there's a lot going on in this problem. So first and foremost, I would just change them to improper fractions and be done with that portion. So I went ahead and did just that, and now I'm going to find a common denominator. 8 doesn't go into 12 evenly, so I'm going to take 12 and I'm going to apply my 2, 3, 5 rule. 12 times 2 is 24, but guess what? 8 goes into 24 evenly, so 24 is my common denominator. So now, as you can see, I have 129 over 24 minus 118 over 24, and now I can just subtract the numerators. So as you can see, the answer you get, as long as I'm not super duper tired, is 11/24. I'm pretty sure that's the correct answer. So as you can tell, the numerators, since they are 5, we are going to just change this into improper fractions, and 57 minus 13 should be 44. So 44/5 will then convert into a mixed number. 5 goes into 44 a total of 8 whole times, and then 8 times 5 is 40, so we have 4 left over, and fifths is going to be our denominator. So you want to make sure to put a box around that. These are probably going to be the most challenging for you to do. I know I drew a picture for the first one, so I'm going to do something a little different for this one. I want you to think about these in this manner. I want you to think 8 minus 3 is equal to 5. Okay, so we know that. So deal with the whole numbers first. Then the second thing is, and actually let me write that. So now, once you know that you're dealing with the whole number 5, so you've taken care of the 8 minus 3, so now what you really have is 5 minus 3/4. So now the way I want you to think about that is you know that your answer has to be 4 something, right? Because 5 minus a fraction will leave you with something less than 5. So you know it's got to be 4. And now you have to think to yourself, well, how many fourths would it take to make a whole? Well, 3/4 plus another 1/4 would make that. So now we know that what we have remaining is 4 1/4. Now, just to check your work on the way back around, you really should look at this and go, okay, just to check, make sure 4 1/4, which was my answer from up here, plus 3/4 should give me a total of 5. And does it? Well, let's see. You have the 4 whole here. I'll change to black. You have the 4 whole here, and then these two right here actually make up 4/4, which gives you that 1 extra whole. So now you have 5. So you want to check that out. Your final answer for this specific problem should be 4 1/4. So you'll see that right there. Make sure you put a box around it. All right, now we're looking at K, which says 3 1/4 minus 1 3/4. Honestly, the easiest and best, most efficient way to probably do these would just be to change them to improper fractions and move on from there. So now I've done just that. We have 13/4 minus 7/4. Then we can just deal with the numerators. So 13 minus 7 is going to give us 6. So now we have 6/4 as our answer. And remember, we are going to need to change that into a mixed number. So 6/4, we can get 1 whole out of that. And when we have the 1 whole, we are left over with 2 1/4, so 1 2/4. But again, don't be too rushed yet, because we still need to simplify that further, and we get 1 1/2. And then don't forget to put a box around your answer. So I know there are quite a few steps here, but keep working and you will get it. And now we come to one of these whole number problems again. So remember the strategy that I gave you when I said deal with the whole numbers first. So let's go ahead and try that strategy again. So we know that we've got 16 and we're going to subtract 5 from it. 16 minus 5 we know leaves us with 11. So now we have our whole number of 11, and we need to think, okay, so if we have 11 and now we're going to subtract 5/6, if we're talking about just 1, think about just 1. So 1 minus 5/6. Okay, so what I've drawn here, first, I'm going to go ahead and erase this 11 that I have here. So we've already thought about 16 minus 5, that leaves us with 11 wholes, right? Now we're only going to take away a fraction, and this is a normal fraction, so it's not a number greater than 1, it's just a normal fraction. So we know our whole number and our final answer is definitely going to be 10. We know for sure that the whole number will be 10. And the reason we know that is because we had 11 right here, and then we're just going to take away part of 1. We don't know, it's not going to be all of 1, because all of 1 would be all 6. So now we need to think about it. We're going to subtract out 5 of the 6. So take those away, and what do we have left over? Oh, we have this one guy right here. So now we have 1/6. So I've shown you 3 different ways to really think about these whole number problems. So hopefully you're able to grasp onto one of them, and then you can use that same one for all of the whole number problems. But again, with this particular, the whole number issue, what you really need to do at the end, once you're finished, is you need to work backwards just to confirm. So what I mean by that is you need to take 10 and 1/6 and confirm that adding 5 and 5/6, so this is my answer, this is up here, should equal 16. So if we think about it, 10 plus 5 is 15, and then 5 plus 1 is 6/6, which gives us a total of, you guessed it, 16. So on these specific problems, the ones that are the whole number minus a mixed number, you definitely need to be working backwards to check your work, and I'm going to be looking for that as well. So now you should be looking at textbook page 302. I'm going to reprint the top part of the question here. You don't have to write the problem completely, but I do want you to follow along with me, and I'll ask you to write down some key points. So it's example 4 says, an urban planner is designing a skateboard park. The length of the skateboard park is 120 1/2 feet. So I need to put an underline there. The length of the parking lot is 40 1/3 feet. Oops. There we go. And what will the length of the park and the parking lot combined be? So that word combined is important. So on your paper for example 4, I would like it to look like this. Example 4, and I would like you to have the following. So what I would like you to have here is, number 1, the word combined. That's important because that tells you what type of operation you're going to be using, which is addition. So then I would like you to look at the problem. Now, of course, we have unlike denominators, so we need to change those into impropers first. And actually, because this problem is so has such large whole numbers, what I'm going to do is I'm going to show you how to do it a little bit quicker. Now, using the improper fraction is usually the best way to go because it's easier for you to find a common denominator and there are just less errors. However, as you can see in this example, what you can also do is add the whole numbers first. So we're going to add the 120 and the 40, which is going to give us 160 right down here. And then we'll find a common denominator with the 1/2 and the 1/3. So now we're going to go ahead and put our 6 there and our 6 here. And then we're going to say, okay, we need to multiply by 2, multiply by 2, multiply by 3, multiply by 3, and we get, excuse me, 3/6, and we get 2/6. So now what we can do is go ahead and just add the fractions. So 3 plus 2 is going to be 5. So our answer over here is going to be 160 5/6. So your final answer here will be 160 5/6. Don't forget to put a box around your answer. Either way will work. If you prefer to do it that way on some of the previous problems, that would be okay with me as well. And now you're here on that separate sheet of paper. If you could go ahead and write 4.5 guided practice. So you want to head your paper as you see here, 4.5 guided practice, textbook page 302, and you're going to do numbers 1 through 4. Thanks, and I'll see you in class.